All right, class, for number 6, they want you to write this in vertex form, x squared plus 8x plus 18 equals y. And probably the best way to do this is to do completing the square. There's a couple of ways you could do it. You could do the negative b over 2a to find the axis of symmetry, and that would work as well. But I am going to do completing the square on this one. So I'm going to do y equals x squared plus 8x plus 18. And I'm going to minus the 18 over, minus 18. So it's y minus 18 equals x squared plus 8x. And then what number is missing right there to complete my square? So I need to do chopped in half and squared. B over 2 squared, which is 8 over 2 squared, which is 4 squared, 16. So I'm going to do plus 16 to both sides. All right. And now I get y minus 2 equals x squared plus 8x plus 16. When I switch that over to its squared term, remember it would be x plus b over 2 squared, which is x plus 4 squared. All right, and then I'm going to add 2 to both sides to get this over here, plus 2, and I get that y is equal to x plus 4 squared plus 2, and that is a vertex form. All right. So let's see what all they want here. They want the x-intercepts, the y-intercepts, the axis of symmetry. All right. So the axis of symmetry would just be negative b over 2a on the original equation, the axis of symmetry. Or you can see right here, it goes 4 to the left. So it's going to be, the axis of symmetry is going to be at negative 4. You could just see it, or if you have to, you could do negative b over 2a. So it'd be, if you go to the ABC at the top, ABC, it'd be negative 8 over 2 times 1, negative 4. So the axis of symmetry is negative 4. All right. And then let's go ahead and graph this thing. I can show you. Even though they really want you to do it by hand, you can prove that I'm correct on this. It's going to be x squared plus 8x plus 18. And you can see the vertex is at negative 4, 2, right? Negative 4, 2. And my axis of symmetry is at negative 4 right here. I can't see my y-intercept. There are no x-intercepts, right? The x-intercept, none. There is no x-intercept. The axis of symmetry is negative 4. Which direction does it open? It opens up, right? It's going up. So it opens up the graph. The y-intercept would be when x equals 0. So let's find it over here. When x equals 0 right here, the y-intercept. So it would be y equals 0 plus 4 squared plus 2. So I plugged in 0 for x, right? And I got 4 squared plus 2, 16 plus 2, 18. So the y-intercept is at 0, 18. There's my y-intercept. And they also want us to prove algebraically that there is no x-intercept. Let me show you how to do that. Let's bring this equation over here. Y equals x plus 4 squared minus 2 And to find x-intercept, you set y equal to 0, right? So 0 equals x plus 4 squared minus 2. Plus 2, my bad. Plus 2. So I subtract the 2 over, and I get negative 2 equals x plus 4 squared, and I square root both sides to get rid of the square, and that cancels, and I get x plus 4 equals plus or minus the square root of negative 2, and that is imaginary. No real solution. So that would prove algebraically that there is no x-intercept on this problem. All right, that is number 6.